Hello everyone, I am Ashish Das. I'm into IT solution architect for last 6+ years, total having 13+ years of experience in IT industry. In the next 30 to 40 minutes, I'll just try to build that understanding of why we need Kubernetes, why we need Docker, and the story related to that. Okay, so I remember an incident around 6 years back. While I was working as a developer, we had a deployment of a major client critical app. I already had handed over the war file and the execution steps to my ops team. However, I got a call in the weekend deployment that the app page is not running. So please come to office as soon as possible. That's kind of a very cliched scenario for each and every developer 6 years back, probably. And my only cliched answer at that time was it was running in my local machine. So if you look at it traditionally, so developers developed the applications. Then they hand it over to upstream to deploy and manage it in the production environment. They do that by providing a set of instructions, such as information about certain software and how to the host file, how it will be set up, and what are the prerequisites and what all the dependencies, etc. Now, upstream use this guide to set up the application. Since the upstream did not develop the application on their own, sometimes they struggle while setting it up. So basically, I had this requirement to set up end-to-end stack, including various different technologies like web server using Node.js, database using Mongo database, messaging service like Redis, or an orchestration system like Ansible. I don't know why the slide is not working. Can you see the slides?
Yes.
Okay. So we had a lot of issues developing this application with all these different components. Firstly, their compatibility with the underlying operating system. We had to ensure that all these different services were compatible with the version of the operating system we were planning to use. So basically, there have been times when certain version of these services were not compatible with the OS, and we had to go back and look for another OS that was compatible with all those different services. And secondly, we had to check the compatibility between the services and the libraries and the dependency on the OS. So we had issues where one service requires one version of the dependent library and another service requires the another version. And moreover, the architecture of the application changed over time. So few of the components got upgraded to the newer version of, and other were using the legacy system. So every time sometimes changed, we had to go through the same process of checking compatibility between these various components and the underlying infrastructure. Also, whenever a new developer join in our team or on board, it is really getting difficult to set up a new environment. So the new developer had to follow a large set of instruction and run hundreds of commands to finally set up their environment. They had to make sure that they were using the right operating system, the right version of each and every component, and each developer had to set all this by himself or by guidance of a team member, eating up their time as well. And we could not guarantee that all the application that we're building would run the same in different environment at that time. So this was actually creating our life hell at the time, and we wanted something that could help us with compatibility issue, something that would allow us to modify or change these components without affecting the other components, and even modify the underlying operating system as required. Yeah, so with Docker, we will be able to run each component in a separate container with its own libraries and own dependencies, all on the same on the same VM and operating system within separate environment or container. We just had to build the Docker configuration, and all our developers could now get started with the simple Docker run command. Irrespective of what underlying operating system they run, all they needed is to make sure they had a Docker installed in their system. And with Docker, a major portion of work involved in setting up the infrastructure is now in the hands of developer in the form of a Docker file. And the guide that developers built previously to set up the infrastructure can now easily be put together into a Docker file and create an image for the application. And this image can now run on container platform and is guaranteed to run in the same way everywhere. So the ops team now can simply use the image to deploy the application. Since the image was already working when the developer built it, and operation team is just they're not modifying it, they're just trying to run it. So it continues to work in the same way when deployed in production as well. So basically, what we learned is that I mean, what are the question we can still ask ourselves: what are containers? Okay, so containers are simply isolated environments, as they can have their own process or services, their own networking interfaces, their own mounts, just as virtual machines. Okay, so now we can imagine this entire kind of little section right here. This we can imagine as an container. So this entire vertical of running processes plus the little segment of the resource that it can talk to is we refer as a container. And so sometimes people say, oh yeah, I have a Docker container. So you really should not think of this being like a physical construct that exists inside your computer, right? So instead, a container is nothing but is a process or set of process that have a grouping or resources specifically assigned to it. We have got some running processes that's basically some sort of process that uh, that sends a system call to kernel. The kernel is going to look at the incoming system call and direct it to very specific portion of the hard drive and the RAM, the CPU, and whatever else it might need. And a person of each of these resource is made available to the singular processes. So we have been talking about images and container as of now. So let's understand the difference between two. An image is a package or a template, just like a VM template that we might have worked with in the virtualization world. It is used basically to create one or more container from an image. Okay, so containers are running instances of image that are isolated and have their own environments to set up the processes. For an example, we can let's talk about an image. We are let's suppose we essentially the kind it's basically a copy paste of very specific set of directory or files. So as we might have an image that contains just for an example shown in this diagram, that is Chrome and Python. An image will also contain a specific startup command. Okay, so here is what happens behind the scene when we take an image that turn into a container. Firstly, the kernel is going to isolate a little section of the hard drive and make it available to just this container okay. And so we can kind of imagine that after a little subset is created, the file snapshot inside the image is taken and placed into the little segment of the hard drive. So you can these two segment basically. And so now inside of this very specifying grouping of resources, we have got a little section of the hard drive that is just Chrome and Python installed and essentially nothing else. So now the startup command is then executed, and then the Chrome will get started in this running process. So now once the Chrome is invoked, we created a new instance of that process, and that created a process is then isolated to the set of resources inside the container. So this is the basically relationship between the container and an image. And it is how an image is eventually taken and turned into an running container. So from an image, we can create multiple container. Yeah, so we can move to the next slide. So then container orchestration, we need to understand, if you want to understand Kubernetes, we need to understand both these word, particularly container and orchestration, and what do you mean by that. Okay, so basically enterprises are now heading towards microservice architecture. Okay, so instead of building a large monolithic application, the focus is to build small microservices. The biggest advantage with these microservices is the flexibility to innovate. I hope you'll all agree to this statement. We can basically build application in different programming language. For an example, we can build this movie service in Go. We can build this customer service in Java. We can build this review service in Python. Okay, we don't really want to build the application in the same enterprise in different language, but we have the flexibility to do that. But the byproduct of going towards microservice architecture is that our deployment will gonna be more complex. Moreover, the way we deploy our application, which is written in Go, will be completely different, may completely different with respect to the application which is being developed in Java. So how do we ensure that we have one way of deploying microservices which are built in different language? So obviously that is where we talk about containers. Just now we discussed that, right? So as we discussed, what we can do is we can actually use containers, that is to create Docker images for each of these microservices. So the Docker image contains everything that we need to run the microservices, and it contains the application runtime as well. So what is present inside the Docker image? So in the Docker image, it contains the application code and the dependencies that the application needs. Pretty much contains everything that we need to be able to run a microservice. Therefore, we'll not have the problems like it works on my local. These kind of problems will not be there. So on top of it, uh, where we would install the Docker engine or the container runtime. So the Docker engine, that also we uh, known as container runtime. So once we have all that, we can run basically Java containers or Python containers or Node.js containers on top of it, because there is no such guest OS on, I mean, which is required for this. So Docker containers are generally considered to be lightweight, and this is an advantage that the containers are all isolated from one another as well. So if there is a problem with one container, it will not impact the functionalities or the processes of the container, the second or the third one. So basically all the containers are isolated from each other. So once we have an container image, we can run it on our local machine or in the data center or in any of the cloud providers. So we can run it in the AWS, Azure, Google Cloud for an example. Each of the cloud providers basically provide a variety of option to run the containers. So now that we have built a container image for the microservices, now we are able to easily run uh, in the container, easily run the containers with them. So basically we have built a, for an example, let's suppose we have built a container for microservice A, B, C, or D. So we want to actually manage the deployment of these containers. So there are requirement arises that we need to auto scale the number of container instances that are running based on the load, and we might have uh, kind of requirement saying that I want 10 instances of microservice A container, 15 instances of microservice B container, and so on and so forth. So just having containers is not sufficient, right? So you would need some kind of orchestration mechanism around these containers. So to manage it. So that is where the number of container orchestration solution comes. If we heard, I mean, obviously we heard about Kubernetes. Kubernetes is just a container orchestration technology. Okay, there are, I know, multiple such technologies available today. So basically Docker has its own tool known as Docker Swarm. Similarly, Kubernetes from Google, Meso S from Apache. So all these are container orchestration technology. While Docker Swarm is really easy to set up and get started, it lacks some of the advanced features required for complex application. Similarly, MesoS, on the other hand, is quite difficult to set up and get started, but supports many advanced features. Anyway, so Kubernetes is arguably one of the most popular container orchestration solution. So when we are using these container orchestration solution, we can say this is the container image for microservice A, and I would want to 10 instance of it. Similarly, we can say for microservice B, I want 5 instance of it or 15 instance of it. And the container orchestration tool will manage the deployment of these containers into clusters. And you will come about the different components of containers in the later slides. So each of these clusters can have multiple servers, and these container orchestration typically offer a lot of features. So when I say features, which are basically these are the advantages of using containers. So for number one is auto scaling. So what is an auto scaling? For an example, we say uh, this is the container image for microservice A, and I expect a lot of load on it. Okay, so would I be able to auto scale? So yes, so Kubernetes provide that particular functionality that it can be auto scale based on the number of requests which are coming into microservice A. So the container orchestrator can scale the number of instances of that specific container. Similarly, service discovery is another feature that is really important in an enterprise architecture. So what is service discovery? So basically, let's suppose uh, we might have a 10, 15, 20, or 100 microservices, and we don't want to hard code the URL of each microservices in another microservice, right? So that is where the concept of service discovery comes into picture. And each microservice can ask the container orchestrators for the location of other microservices, and thereby we really don't need to hard code the URLs. So this service discovery features is also provided by Kubernetes. So as soon as I start talking about multiple containers, we need to talk about the load balancing as well. And this is one of the, again, very important feature in the enterprise architecture. So once I have a multiple container, I want to distribute the load between them. So container orchestrators also provide load balancing, and uh, along with that, we also need resiliency, right? So if one of the instances of the microservice is not working properly, so I would want the container orchestrator to identify that and replace it with the working instance. That is where we can actually configure health checks, and container orchestra can execute frequent health checks and replace failing instances. This is also called self healing. Not only that, so we also can sometimes we want zero downtime during the deployments, right? So at that time, we might want to go from let's suppose we have a microservice of version A, and we want to go from version 1 to version 2. So in the traditional environment, obviously we need to take it down and then install the new version, and obviously there will be some downtime. But in this case, the containers orchestrators, they provide number of strategies, so to release the uh, new app version of software without even downtime. So there are concepts like such as canary deployment, etc. So with this, only splitting of traffic will happen only for segment of the users, and once that is successfully tested, then only the app version will be available for the other sets of users, and that too uh, in a controlled fashion. So that is also a very important feature in the modern application and modern enterprise application. So coming over, if we talk about a little bit about the public clouds, so all these cloud providers provide Kubernetes managed service, right? So for an example, we have EKS, which is provided by AWS. Okay, so it's known as Elastic Kubernetes Service. Similarly, for Azure, there is an Azure Kubernetes Service (AKS). Similarly, we have GKE, Google Kubernetes Service, which is provided by Google Cloud Platform. Yeah. So in addition to these services around Kubernetes, so these cloud providers also provide other services around containers. For an example, AWS provide ECS, that is Elastic Container Service. Similarly, Google also provide Cloud Run, which is a simple service to run simple containers. So if you want to cut the long story short, so Kubernetes is nothing but a container orchestration technology used to orchestrate the deployment and manage hundreds and thousands of containers in the clustered environment. Okay, so this is the container orchestration, and we touched about what is Kubernetes. I just want to cover a little bit of basic architecture of Kubernetes. Okay, so majorly we have nodes. Nodes is nothing but a machine or a compute engine instance, and a cluster. Obviously, in the nodes, we'll touch upon what is worker node, what is master node, and obviously we have cluster. Okay, so let's talk about the cluster. Cluster is where we run our workload. Okay, whenever we want any deployment, we have to deploy something in Kubernetes, we want to first create a cluster, and a cluster is nothing but a group of compute engine instances, or in layman terminology, group of computers. Okay, so there is a master node which manages the cluster, and there are worker nodes where actually it run our workloads. So inside the master node is also known as the control plane, because this is what is managing everything. So whenever we execute any command, so basically we execute a kubectl command in Kubernetes, we are sending it to the master node, and the master node will do the whatever is the necessary steps to execute the command. It manages the cluster, and it says, yeah, I mean the mm, master node, it says that okay, I got a new code, so hey, do you want to deploy it, or I want so and so instances to be deployed. So the master node is the one which manages the cluster, and the worker nodes are where our workloads or our applications or microservices run. And as a part of this master node, there are a number of components. The first one is the API server. So there is a lot of communication which happens within the Kubernetes cluster, and there is a lot of communication that happens from outside to the Kubernetes cluster. So while executing the command, part of the master node receives a request for a command that is known as an API server, and this manages all the communication for a Kubernetes cluster from outside. Similarly, the next important component is the scheduler. So when I uh, when I say, let's suppose I want to create a deployment with 3 parts. So what does the master node needs to decide? So let's say there are 10 worker nodes. So it needs to decide which is the worker node where the instances of the deployment need to run, and the component in the master node. Also, which so all these features, all these things is decided by the scheduler. So is it is it sufficient if you just deploy the things? The answer is obviously you we'd also need to manage if they are healthy. So that is where we all discussed already related to the features what it provides. So it has self-healing, health checks, etc. So if any of the pods or if any of the services is not healthy, so you need actually to replace them. And that is why we have a control manager, which is, the control manager manages the deployment and the replica sets. Okay, these are again terminologies or components inside the Kubernetes. So yeah, so a little later, basically, we'll discuss what is the difference between a deployment and replica set, probably. The fourth important master or component for the most one of the most important component is also etcd. So etcd is what? It is a distributed database storing that the state, it stores the state of the cluster. Yeah, so obviously there are a lot of things inside the architecture of the Kubernetes. Probably we'll bring this in the subsequent presentations or in the subsequent sessions. So yeah, so that's it from the master nodes. For the from the worker nodes also, okay, it has mostly the pods. So basically, pods can be defined as the smallest deployable unit inside the Kubernetes. Okay, so yeah, there are few components in the worker node as well, but the most one of the most important is the kubelet. So what is a kubelet? So uh, in the worker node, there is a specific component related to the Kubernetes, which talks to the master node, and that is what kubelet is. It basically it manages the communication with the master node. Yeah, so there are other things also that we'll gonna cover in a detailed session in the forthcoming weeks. Yeah, I think that's it for today. If you have any question, you can just pop it up. Thank you.